So just a quick introduction. As Big mentioned, I'm a senior product manager at Microsoft working on AI. I've been doing it for quite a few years now, even going back to the very early days of ML.NET. So that's still happening. The focus here for our conversation is going to be mainly around generative AI, because that's the thing that folks seem to be really excited about, and rightfully so, right? Gen AI seems to be democratizing to some respect access to AI, and doing stuff that used to be really, really hard is now easier to do, right, with Gen AI. That said, in the .NET ecosystem, right, we have a ton of solutions, and actually some of those solutions are even powering some of the samples and demos that I'm going to be showing here, right, that although they're not Gen AI specific, certainly they're applicable throughout, throughout your AI app building process. Right? So no slides, it's just going to be me talking in demos here. And so hopefully that's all right with you folks. But I'm going to kind of kick it off here because this blog post that Jordan, my colleague, and I authored fairly recently really provides you a really nice overview of a lot of the things that the team is doing in the .NET ecosystem when it comes to building AI applications, right? And so I would encourage you to, whenever we get a chance, we can maybe share the link here. But effectively, there's a lot of stuff that we are sort of doing here in the AI ecosystem for helping .NET developers build AI applications. First and foremost is documentation and samples, right? So there's a ton of samples out there, some of which I'll be showing today. They can sort of reference, and there's samples from a variety of different difficulty levels, from just like barely getting started, learning about what is Gen AI, the different components, how you go about building these applications, right? So a lot of quick start and introductory material. But at the same time, we also have sort of more enterprise ready or enterprise grade versions of these applications that are leveraging AI to perform, tasks, right? And so I'm going to be showing both here. Again, you can have the links are here towards where those samples live, but one of the main places that you're going to kind of want to go to is this .NET/AI samples repository. And again, that's included in the blog post, right? But you're going to see again that there's a whole bunch of samples here, that you can use to kind of get familiar and get started with AI. Let me kind of go back here. And so one of the things that you may have seen from that repo is that it's using semantic kernel, right? And so what exactly is semantic kernel? If you haven't heard of it, semantic kernel is a library, it's open source. And it enables you to connect various components that you might need for your AI applications, right? So for example, one of the main pieces that you're going to be working with when you're building these AI applications is a model, right? The model tends to be a core to this experience. And the model here is, it could be GPT, the one from OpenAI, it could be the one from Azure OpenAI. There's even support for Hugging Face and a few other models, which I'm going to be kind of showing here today in a little bit. But in addition to that, right, it's not exclusive to the models. At the end of the day, data is really what makes these models actually effective, right? So these models were not trained on your data. They do not have any context about your data, right? And so how can you make these models more useful to your scenarios, right? And so that's where you sort of have databases. One of the ones that has most recently been popping up are vector stores or vector databases, right? And in the .NET ecosystem, we've been working with those respective communities to sort of build official SDKs for solutions like Quadrant, Milvus, Azure AI, right, which is Microsoft's product. But across the board, we've just been working in enabling a set of these SDKs to be built. And then on top of that, enabling semantic kernel through connectors, just like the models, to make it super easy for you to sort of compose and build these applications, right? Using, again, those various components that you're going to need as you go and develop these apps. Again, right, one of the things that's super important is, okay, well, great, I can start with those beginner samples and those introductory samples, and that's going to get me so far. But at the end of the day, what I really want is I want to be able to sort of put my applications into production, right? And it was announced that, or it went GA, generally available at Microsoft Build about a month ago. But .NET Aspire provides a lot of really nice sensible defaults, right? Such as configuring telemetry, resiliency, and all of these different aspects that are involved when building, applications, but particularly cloud native applications, right? And I'm going to be showing you a little bit as to how this, is a really nice way to build these applications, these AI apps, right? And how AI can benefit from the things that you just get out of the box with Aspire. We are innovating at all levels of the stack here, really. And so while Aspire, that's sort of, more of the application framework, the stack that you're using to build and compose these different components and resources for your applications, right? We are working on enabling, all types of different scenarios low down at the runtime level, right? And so there's a few set of libraries and new types that we're introducing for AI applications just to enable .NET to just be very effective at handling these AI workloads, right? And so most recently, one of the ones that we announced was a tensor type. So effectively in AI, everything is represented as numbers, and typically those numbers are represented in sort of these multi-dimensional like data array data structures, right, that are known as tensors, right? And you apply operations, you do transformations, you do all sorts of things on these tensors to get the model to perform or produce a result, the result that you expect, right? So you use these tensors to manipulate and apply computations in the context of AI. And so Tensor is coming to .NET 9. And again, right, like it's just going to enable more efficient data processing, data sharing between the various libraries or frameworks like ML.NET, Torch Sharp, Onyx, and a few others. We are also working on things like tokenizers, right? And so tokenization is, again, one of the critical pieces for these language models. Basically, what a tokenizer is, it effectively, the piece of text, computers don't really know how to process text as is. So again, you need to convert those into numbers, right? And so the way that you do that is it's through a process typically known as tokenization, where you break down the sentences into individual words, if you will, or tokens, and then those tokens get converted into numbers that you can then pass to these models. You can use them for cost measurement, right? So, for example, with the various services that are out there, you typically are charged by certain amount of tokens that you're using as part of your requests and the responses. And so, being able to inspect and visualize how many tokens am I actually using per each of these requests is super useful, right? Now, we've been talking a lot about services so far, but we have seen that there's a new sort of generation of models that are coming out that are smaller, right? Not small; they tend to be called small language models, but there's still quite a few gigabits, right? And so that's something that also in the .NET ecosystem we're working to enable. And so we're working with teams throughout Microsoft, like the Onyx Runtime team, who recently introduced this Onyx Runtime Gen AI library, which enables you to use models like Phi, right, for working with models at the edge, right? And so you have a small set of models that you can sort of use for inferencing, instead of services. Sort of caveats there, right, and trade-offs is that it's not it's not sort of like a one-stop shop solution, right? Again, because these small language models tend to be smaller. Their capabilities are, significantly diminished compared to sort of the larger models that are out there, right? So again, depending on what it is that you need, whether it's, a larger model that has more capabilities or a smaller model because you have, certain, privacy, cost, latency requirements, whatever that may be, storage requirements, right? Small language models may be an effective tool for you. And again, regardless of where you land on your architecture and your needs, in .NET, we want to make sure that we're sort of supporting you here. And again, there's just a growing ecosystem. We kind of talked a little bit about some of the work that's happening with the vector stores, right? Like Milvus and Quadrant. Recently, there was an announcement for the official OpenAI library for .NET. So basically, this is, again, it's a library that Microsoft collaborated with the OpenAI team on developing. And so now, effectively, any sort of features that come out or are announced from OpenAI, effectively, this library is going to provide, support for those on day one, right? And there's a lot of, other benefits to it. There's a ton of other stuff here, but the one that I kind of want to sort of also touch upon is I mentioned that Azure AI Search is one of the sort of solutions that's out there for leveraging as a data store and a data source when building these types of applications. But at Build, there was an early access preview announcement for Azure SQL Database. And so Azure SQL Database will now introduce or has introduced vector support, and that's currently in access preview. So you can go ahead and check out, the blog to learn a little bit more about, how you might be able to leverage Azure SQL and its vector support to build these types of applications, right? And then if you're interested, just in terms of case studies as to, how folks are using, folks that are building AI applications, H&R Block was kind enough to share some of the things that they're building today. They currently have a product or a solution in production that's leveraging generative AI and .NET and a variety of sort of the services and tools that we talked about throughout this post, right? But if you want to learn more, you can kind of, just dive deeper into this. And there's a build talk that was done. Vin from H&R Block joined us on there, where he details a little bit more sort of the architectural patterns of what H&R Block did, but also some of the lessons learned as they were building this application and going to production. Okay. There's other resources that I can send to you, but effectively these are all part of the part of that blog post that I mentioned. But again, I mentioned small language models. Bruno from the team, he went ahead and published this blog post, which kind of talks about some labs that I'm going to be showing here today that show you how to use 5.3 with C# and on its runtime Gen AI library. There's more details here as to the official OpenAI library, which again, it's part of that blog post. And with that, let me just kind of jump right into sort of some of these demos. But as I'm pulling these up, just want to see if there's any questions. All right. Nothing?
We have, some questions.
Okay.
Hossein is asking for, can I customize the download user information so that the user can download the various files or information he has uploaded from the system?
I guess he has asked this for ABP Suite because it supports generating the file property type. And yeah, you can definitely customize it. You just need to select the customizable code support, and then you can follow the documentation, and you can add any type of your custom code in the related hook points and customize the related parts. Yeah.
Okay, coming up another one. Is the session management SSO compatible? I think that's more for ABP.
Yeah, it's also compatible with the single sign-on. Yeah.
All right. Well, you guys, if you have any questions to Luis, I would suggest you to write them down in the chat section right near to us, or down, whatever you preferred, on your YouTube. And coming up, another ABP-related question. In this version, 8.2, Session Manager is available for Blazor server.
Okay, he means session management feature, I guess. Yeah, it's available for all of our UI types.
I see. Okay. Let me search for another question if we have any. It seems like we don't at the moment. Well, if you guys have any questions, please just write them down and we'll be happy to answer them.
Sweet. We switch up, bring the screen back.
Yeah. And also what we were, okay. Oh, you have also codes. Exciting.
Yep.
Okay.
From here on, it's all code.
All right. Okay, then. Well, we can move forward and we'll see if they have any questions then.
Perfect. Okay. Yeah,
All
we
right,
can do the Q&A at the end. Yeah, no worries. Yeah, let me just jump in then.
right.
So as I mentioned, one of the things that the .NET ecosystem sort of provides is the semantic kernel library, which, as I mentioned, it just enables you to compose and orchestrate the various services out there, right? And so in this case, what I'm going to be doing is just initializing a basic chat just to kind of like get familiar with like, hey, how do you go ahead and build these types of applications with semantic kernel and some of the basic components. And then we're going to go and show this more in a production like application. Right? And so in this case, you're going to see that I'm just providing the model name. In this case, it's GPT-4. I am initializing a kernel. A kernel is sort of like the central, if you will, repository or sort of central unit that is leveraged by semantic kernel to register the various services and components that you would need. So that's where you would add stuff like this chat completion service, right? And this one's using the OpenAI set of models to do that, right? And so what we're gonna see here is that we're just providing our key, right? Because you can go to OpenAI. In this case, we're using OpenAI, not Azure OpenAI. And so what's happening here is I'm just providing the key and I'm saying like, hey, I want to use the GPT-4 model, okay? And then all I do is build, right? So effectively, this is just kind of like a service collection. It's a container, right? Where we're registering all these services. And then we just do a loop, right? Where we ask a question and then we invoke the prompt, right? Which is the prompt is what I'm sending, the message I'm sending to the language model here, OpenAI language model. And then I'm going to get a response and just print it out here. So if I were to just do the CD sample one, make this a little bit bigger, just to, oops, turn them off. All right. So if I do .NET run, should pop up in a second. Now it's asking me for a question. I ask, what is AI? Okay, and so we're using the GPT-4 model here. And so after a while, it's going to send it to the service and it's going to come back with a response. Cool. Now, one of the interesting things is that semantic kernel makes it super easy for you to switch between services and just components. So in this case, what I'm going to do is I'm going to uncomment this. And actually what I'm using here is an Ollama model. So Ollama is this sort of tool that enables you to sort of download the various open source models like Llama, so on and so forth, right? So if I go Ollama list, you're going to see that I have Llama 2 and Phi, the latest sort of version of the model. And so what Ollama also does is it provides you with this sort of server that sits in front of these models, right? And this server effectively follows the OpenAI conventions, right? The completion set of URLs and path names and API specifications. Right? And so in this case, you can see that now I'm not using OpenAI. By default, it's going to use OpenAI. In this case, I'm still using OpenAI, again, only because it's compatible. And in this case, I'm just doing it to kind of show you how easy it could be to switch these out. But now instead of using GPT-4, I'm going to use Phi. Right, and there's the endpoint that Ollama is listening to on my machine. And so if I were to do .NET run, what is AI? We should see that after a while, it's going to respond to us. In this case, it's a little bit slower because I don't think it's using my GPU for this. But you can see that it also comes back with a response. So that's how easy it is to kind of switch back and forth between, whether you're using OpenAI, and in this case, we're using a local sort of, version of the Phi model that's running behind a local server. So cool, this is awesome, but the problem is that now I'm not remembering any of the chat history, right? And so what you can see here is that semantic kernel also provides you with a chat history component, and this is basically a collection of messages that as you go through the conversation, you're able to remember, sort of keep track of the previous messages, which you can then use for like, if you needed to ask a follow-up question about something, you can leverage the chat history, right? And so if I were to sample one, then, let's see, CD sample, sample 2, run. If I were to kind of run this one here, I ask it, what is AI? It's not going to be much different. The only difference that's going to happen here now is that okay, yeah, that's great. So if I were to ask it now, which car color do I like? You see now red car. So now we're leveraging that chat history to then sort of inform future responses. And so that's kind of one of the benefits that sort of the chat history provides you. Okay, cool. But I already have some code, right? Again, the models themselves don't have, don't know your data, they don't really know your processes or anything like that, right? So how can I basically use these models and build these applications that leverage my code, right, that I've already written to be able to sort of use in my application, right? And so in this case, you're going to see it looks very similar. The only difference, or one of the main differences here, is now we're saying import this plugin, right, from type, and we give it this demographic info. All demographic info is, it's a class, right? And this class has a single function called get age, which just takes in a name, and then based on the name, it will return what that person's age is. And then we just decorate it with this kernel's function. That way, semantic kernel knows, like, hey, I know I need to register as part of the tools or as part of the functions that are available to me for me to do something, to do a job, right? But then other than that, it's the same thing, right? I'm getting messages from the user. I am, adding them to the chat history, and I'm doing all these things. So if I were to do sample3, right, and then I would say run, it's going to come up in a second, and then I will ask what or how old is Alice? Oh, interesting. Is it case sensitive? It's literally worked right before. Oh, there you go. Okay, so there was a little bit. Okay, so that was my fault, user error. Because this is case sensitive, it actually failed as expected. But you can see now that Alice is 25 years old, and so it used the information from calling this function to be able to retrieve information about how old Alice is. And so you can imagine having a bunch of functions. Maybe you already have class libraries. And if you decorate them with, you decorate them as appropriately, you can use them as plugins as part of the, with semantic kernel. And how exactly do these sort of tools get called? You basically just use this auto invoke kernel functions, right? And there's different behaviors that you can kind of set here as to like how you want to control this. There's also logging. So in this case, you kind of see that you don't really know what's going on behind the hood. But again, because this is just .NET, you can just say, hey, I have this sort of service container, right? And I just want to add logging. This is just your standard dependency injection, your logging extensions here, right? And you're just saying, hey, to the console, just output anything that's coming out from these, from the information that I'm getting from these libraries. So if I were to go to sample 4, run that one, we're going to see that we're going to get a little bit more information because now we're doing logging. And then this is called, let's see, now if I say, what is AI? You can see that we get more information here. We see the chat history that's available to us, right? So that's effectively what it looks like. You see that this is the response that gets generated. And then in addition to that, you get that information about, how many tokens were used as part of this request, right? And so you can, again, use this information to, understand costs or understand whether you're at your limit, because these models tend to have a context limit of how many, tokens you can pass at any given time, right? So you can leverage this information downstream as you're building these apps to, to do stuff with it, right? So cool. This is in the concept, in the context of a console application. What does this look like if I were to write a web API, right? So again, if you're familiar with web APIs and ASP.NET, this should look very familiar to you. You can see that a lot of the stuff is mainly different, but instead, in this case, I'm just leveraging the dependency injection and the extensions that semantic kernel has built just to work very nicely with ASP.NET, right? So in this case, we just say add kernel, right? So that's, again, the thing that's sort of collecting all the things that we're building. We're adding a chat completion service. Again, very similar. We're just passing in the model name, GPT-4, and our key. And now that that's available, we can just say, hey, invoke prompt async. And in this case, what it's going to do is it's going to provide a short description using the temperature information. This is just randomly generating weather information. But it's going to output this really nice description for me, right, that you might display in your UI or whatever it is, right? So if I were to do .NET run on sample 7, it's going to start up my my web API. Oh. Oh, whoops. No, it's already running. Shut it. now it's listening on 5175. And if we were to do a curl this request, so I go to curl forecast, right? That's the endpoint that we're using here. And we hit that. And now, for a few seconds, part of the latency here is from it generating the response. See, there it is. See, so it uses temperature, which is -6, and now here's a short summary of the weather at -6 degrees Celsius. Typically during winter, so on and so forth. And so in this case, right, we're leveraging the information that we're getting about the temperature to then generate responses that are more human friendly. And you can, again, right, you can imagine taking this and then downstream, you can just display it in a UI, do all sorts of things with it. Okay, cool. So this is, this is the sample, right? How you can use semantic kernel. I'm going to kind of bring up another one showing you how to use the what's it called? The Onyx Runtime Gen AI library. So the difference between the Onyx Runtime Gen, or one of the difference between Onyx Runtime Gen AI library and Ollama is that the Ollama models are effectively running behind a server, right? Versus in this one, so you need to go and make requests, right? Like, so HTTP requests, you need to go over the wire to get those responses from the models that Ollama is sort of hosting for you, right? In this case, with Onyx Runtime Gen AI, everything is effectively running in process, right? So you're not hitting some server, you're actually talking to the model directly. And so you're going to see that a lot of this looks very familiar. We're creating our kernel builder. We are adding this Onyx Runtime Gen AI chat completion, right? So again, the chat completion is sort of this interface, and literally anybody can implement. And that's how you're able to have different types of models, like Phi. You can have GPT, and any of the other models that are out there, right? You can just, if one doesn't already exist, you can just go and implement the chat completion service, and now you have a standard interface that you can use for using the different models. In this case, we just have a model path. I have so the model files and all the information that we're going to need to load in this P3 CPU folder. I'm just going to go ahead and load that and make it available to semantic kernel so that I can use for chat completion services, chat history, all the stuff is still there. And you can see there's literally not much that's different here. The only difference that instead of invoking prompt async, we just say get streaming chat message content. Effectively, it's doing the same thing, right? So if we were to do .NET run here, you're going to see that the interface is fairly similar. Just give it a second, okay? And if I were to ask what is AI, that's the response I'm getting back from P3, right? And so what the streaming response is, you can see that as opposed to waiting for the entire response, it's just streaming word by word, right? And so depending on what your needs are, you can sort of switch back and forth between, whether you need Onyx Runtime Gen AI, whether you need the OpenAI or the other service-based models, right? It's super easy for you to go switch back and forth with semantic kernel. So that's it for the models, but I think I may have like a minute or two here. So let me just kind of show you in the context of Aspire what this kind of all looks like. So if you're not familiar with Aspire, this is a lot of projects. Let me just kind of show you what this application is. As I'm pulling that up, I'm going to start this so that it can be ready when I start talking. But what I'm going to be showing you here is this eShop application. This is basically a cloud native sort of app. It's using Aspire for the orchestration of the various resources, and effectively it is a sort of a e-commerce site for outdoor gear, right? And so there's various components here, particularly the catalog service, right, which contains the all the products. And our web app, right? Our web app contains a chatbot that we can use to ask information about our products, right? And so if we kind of go back here, we can see that this is your app host project instead of Aspire. So your app host is where you define all of your resources. And you can see that these components like Redis, RabbitMQ, Postgres is my database. So all the things that I need are sort of being configured here inside of this project. And if there's any references that these projects need, for example, in this case, right, I want to use OpenAI in this case, and I'm actually leveraging the OpenAI set of components that Aspire provides me with, right? I just give it my connection string to my resources, And this basically configures an OpenAI client for me, right? And makes it available to my application. So you're going to see here that my catalog API is going to be using an embedding model. And I'm just saying like, hey, reference that OpenAI resource and configure all the connection strings and everything that you're going to need in order to make an OpenAI client available to the catalog API. Do the same thing for the web app, but in this case, I'm using a chat model. Okay, so let's kind of take a look at what the app looks like, if I can find it. There we go. So when the application starts, you can see that all the resources that we defined, there's Redis, there's Postgres, right? There's our web app, where's our catalog service? There's our catalog DB, right? There's all these services are just available to me here in the Aspire dashboard. If I were to open up the web app, for example, you're going to see that this launches me into the site. I can sort of open up the chatbot and I can say, hi, how can I assist you? I'm going to ask it, do you have any watches for sale? Should do a good enough job of watching for my typo. And you can see here that it went out to the database. It retrieved a set of watches, right, that are available for sale. And it just displayed them here for me, right? But what's actually really cool is, again, Aspire just gives you a lot of sensible defaults out of the box. So beyond the dashboard, right, the dashboard's pretty cool. You can sort of observe things. You can kind of view the details, right? You can see any sort of the ports that it's listening on, any of those sort of connection strings, right, that it might need are sort of available to it. But the other really cool thing is that you also get structured logs, but more importantly, you get these traces, right? So you get full observability with the telemetry that Aspire gives you out of the box. In the context of AI applications, we can inspect what actually happened when I was chatting with the chatbot on that web app. If we dig a little bit deeper here, you're going to see that this is a chat completions sort of event that took place. This is the entire trace. You can see that it went out to my catalog API to try to find data. If we kind of take a look at what that looked like, this is actually the query that was written, right? So you get inspection to what query was sent to the database. But more importantly, if we were to check out the web apps here, you can see that there's information about the model that was used to generate the request and certain parameters like temperature, top P, how many tokens were used, right? So you get this really rich information displayed for you here. So that's really nice. And what's actually even cooler, also the stuff that really excites me is you might think, okay, well, I went through this really complicated process of sort of setting up the observability and all that stuff. But actually, if we go over to our service defaults here, we can see that this is where you configure all the services that are made available to your application. In this configure open telemetry sort of extension, you can see that well, actually, let me take a step back. So to enable it, I just set this switch. I'm saying, hey, this is this experimental feature for diagnostics, enable it. And then once that's set up, you can kind of just see here that I say, hey, for open telemetry, I want metrics for anything coming out of the Microsoft semantic kernel set of packages. And I also want sort of tracing, right, available for anything that's coming out of semantic kernel. And that's it, right? That's all I need to do, and I get all of that rich information out of the box. So I'll kind of pause there. That's kind of the end of the talk. I hopefully didn't go over too much, but yeah, I'm happy to take any questions.
Thank you so much, Luis. I think that was insightful, and now we have over 12 questions actually, so we can do them one by one. Again, some of it may be ABP related, but we will do that just along the way. Session Manager is also available for Angular and question mark. So is it available?
Yes, it's also available for Angular, right? Yeah.
All righty. Do you think that .NET technology is well positioned or aligned itself when you compare other frameworks? I think this could be. I think this could be for either of you guys.
I guess it's related with ML.NET framework.
Yeah, so I can sort of speak to this one, right? Well, first of all, what I would ask is for additional clarification in terms of like well positioned for what, right? Like what exactly are you optimizing for? And so in terms of, building enterprise applications, as we kind of just saw with Aspire, solutions like Aspire, it makes it super easy for you to build these really complex applications that have a lot of dependencies, right? One of the things I didn't show is that when you do ACD up using the Azure Developer CLI set of tools, right, you can just very quickly and easily deploy into Azure. But even before Aspire, right? Because Aspire is the new thing that was announced at Build. But even before that, right, Aspire is basically just bringing together a lot of those things that have been learned in terms of patterns and sort of, practices for building these types of applications. It makes it super easy for you to sort of build and deploy these apps. But again, right, even before that, we had, with .NET, there was, a lot of performance, a lot of, sort of battle tested components in .NET, right? That when you're ready, when you want to build enterprise applications, it makes it super easy for you to do that. Or at least that's the goal, right? So I hopefully answered that question. But again, I would ask for clarification in terms of what exactly is it that you're optimizing for?
All right, then we will ask for more specific questions and, just a bit detail about this question, if he's still here with us. Moving forward, David is asking, I wonder if using these Azure OpenAI libraries can create a bot to provide support for the software or systems we develop. How could the model be fed?
So the model, as I kind of showed, right, let's just kind of take it a bit back here to the sample one, right? You can see that the actual process, in this case, it knows that because I'm talking to OpenAI, it knows what the default endpoint is, right? So it knows where it needs to send the request to. And again, right, I obviously need to provide my key because that's the thing that, that's how it's going to know and authenticate and know that it's going to make a request on my behalf. But other than providing the model name and configuring this piece, right, and providing my key, that's all I really need to do in order to start calling these models, right? And that's, generally across the board, that's the thing, right? You have an endpoint that you're hitting, you have some sort of credentials that you're providing, and then, you make requests to the respective models.
All righty. Next up, we have, in which cases we should use Phi or GPT-4?
Yeah, that's a good question. So again, one of the things that I sort of mentioned is that because of their size difference, the capabilities are going to be significantly, different, right? So Phi is actually really good if you want to just like start, prototyping, testing stuff locally, or if you have a really super specific thing that it is that you're doing that's like relatively, what do you call it? That it's relatively simple or not very complex. And so in that manner, right, it's really easy for you to get familiar with like writing prompts and like sending requests to the LLMs and like, providing context, maybe even doing RAG, patterns like, retrieval augmented generation to inject data and context for the model to generate responses. And so if, that's the places where Phi would shine really nicely in scenarios where, for example, right, you cannot be making requests to services, Phi is a really good solution. But again, right, in terms of the capabilities, right, you're going to have a bit of that trade-off in terms of capabilities. The other thing with sort of, for example, outside of model capabilities is like, even though, for example, I can go and download Phi and start using it locally on my machine, if you wanted to kind of go to production, right, you're basically taking ownership of that component in your software development pipeline, right? And so as a result, you're going to have to deal with all the ops that are associated with it. So again, one of the things that you're going to have to ask yourself as you're building these applications is like, is it better to build or is it better to buy, right? And in some cases, build is going to be better. And so Phi would be really nice for that scenario, assuming that the capabilities meet your requirements. Or you can be like, this is not a core part of my, this is not something that I'm really signing up to do. And so the services, the buy approach might be a better way of doing that, right? So it really depends on your scenario, but hopefully I answered that question, Mariana.
Thank you. Let's hop on to the next one. Can I create the Llama artificial intelligence model as a .NET Core Web API and use it on my own systems?
Well, the way that I would kind of answer that is like, can you use one of the open source models that are out there like Llama as part of a web service? And the answer is yes, right? So in this one, we did add OpenAI chat completion, and we're using OpenAI. But as I showed in these other examples, right, if you switch it out to using something like Llama or using something like in the other example, what was it? fee, right? Like in this case, I'm saying like add Onyx runtime Gen AI chat completion, right? As long as I have some sort of chat completion service, I can then use it inside of my web API as I kind of showed in eShop, as well as in this sample, right? Where I'm just saying invoke the prompt, use the temperature to inform, the response, and sort of, go about it that way. So long story short is yes, you can.
All righty. What tools does .NET offer for debugging and diagnosing AI applications?
Yeah, so I would ask for some clarity here as to specifically what you're looking like. What do you mean by debugging and diagnosing? But some of the things that I kind of just showed here, right? Like are a step in that process where it's like, hey, if something went wrong with the with the request that I sent to these models, right? I can use the observability components of the auto telemetry information that's being generated to be able to say, oh, okay, like this at this step in my workflow or at this step in my request is where it went wrong, and then I could sort of start digging deeper into okay, well, what can I do to go and fix that, right? So that's one way you can go about it, but I'm not sure if you're looking for something more specific, Mohammed.
Alrighty. Again, more specific questions, you guys. Thank you. With .NET, can we use local LLM that comes with integrated in Windows Copilot plus PC?
I believe so. So there's this thing called the Windows Copilot runtime that you might want to take a look at. There's a few samples. I'll try to find it and I'll share it with the folks here to send it after. But the short answer is you should be able to. And I'll send a link to that. Oh, and then obviously, like if you wanted to use sort of like because at the end of the day, right, these are effectively using to a certain extent the Onyx runtime Gen AI set of libraries. So if you wanted to sort of do that, you can do that in the way that I kind of showed here with these labs. And by the way, these labs are sort of like they're online, they're available to you, so you can kind of walk through them at your own leisure. So.
All righty, thank you. So for your geographic info, can we use it to build offline module?
No. So demographic info in this case, all it's doing is it's providing functionality that the model can use. It's not actually training a brand new model. Let me kind of just switch back here to kind of show that. Is this the one? Yes. So sample 3. This is not actually doing or training a new model, right? This is just providing additional functionality to the model because the models at the end of the day, they don't do anything, right? They can't take action and they don't have access to your data, right? And so you need to be able to provide either access to your data or access to some sort of functionality that the model can invoke, right, to perform actions on your behalf, right? And so that's effectively what this demographic info class, specifically the get age function, what it's doing, right? So it's not training a brand new model.
All righty. Are there any database design requirements for AI model integration?
Not specifically. So one of the things that I kind of, brushed on, and we can have a whole separate conversation on that is the being able to leverage embeddings for quick search and retrieval of semantically related context, right? So if you have access to those, which again, as I mentioned, the Azure SQL is providing, support. It's in preview right now, but they're introducing vector support. Postgres has this already, a few others, Cosmos, Mongo, right? They have some of these capabilities. So chances are that, with the set of, with the set of databases that you're using today, more and more of them are introducing this vector support to make it easier to search. At the end of the day, though, vector search is useful in some scenarios, right? But, you could just as easily run like like a SQL query, right? Like if you knew kind of like, hey, I need to search for certain products, you can run a SQL query, return the SQL query results without any vectors for that matter, right? And then just, put those inside of your prompt to be able to help you generate a response, right? So it's not a requirement to have vectors. It helps, but that would be like an additional component that, you might consider, right? But you can just as easily just run SQL queries, with the data that you already have, and sort of use those as context for your model to generate responses.
All right, thank you. Do you think it's better to use C# or Python for AI processes? Can we use a bus to communicate between Python and C# services?
Yeah, so I know that there's a lot of projects out there in terms of, to communicate between Python and C Sharp. One of the things that, if you kind of wanted to have some of those integrations, that might be easier, to be honest, is, you put it behind a service, right? And if you want to integrate into your .NET application, you just call that service, the Python service, which makes it super, it makes it easier to use in some cases, right? Obviously, that's not a one stops, sort of like the end all solution, right? There's many other solutions that you might consider, right? But that's one way that you could do it.
All righty. Can I provide context to my model, such as PDF, to prevent hallucinations?
Yeah, you can, right? So assuming that you extracted the data from the PDFs, right, and you have it in this organized format, one of the things that you're going to have to consider as you're doing that is, like, you can't shove an entire PDF. I mean, depending on how big the model context is, as I mentioned, right, there's only a limit in the number of tokens that you can pass to a model. So assuming that you're working with data that is sort of relevant, right, to help you answer whatever questions or tasks that you're performing on the PDF, as long as you take care of that, the answer is yes. And actually, it's recommended that you ground these models with actual, factual data, right? Because otherwise, this thing is just generating tokens, right? It's just generating words, and it's like, yeah, that sounds good, without actually checking anything, right? And that's where the grounding with the data really comes in. And again, right, that could be a PDF, that could be, results from a SQL query, like it could be a variety of things. The point is, you're grounding the responses on actual data.
All righty. Well, Adib is saying he's having a hard time understanding token concept. Could we use your experience and try to explain it in simple words?
Yes. Let me see. Let me kind of show you what a token is. Maybe. Let me just double check. Verify that you're. Let's see. Okay. This is the one I'm looking for. Yeah. Okay. So a token is just breaking up words into sort of sentences or larger chunks of text into smaller words. So if I were to say, hello, community, right, you can see that there are 32 characters. Each of these, I'll just bump it up a little bit. These are sort of split up, right? So it's easier to process. But then if we were to switch over to token IDs, what the models are actually getting are these numbers, right? They're not actually getting the raw text, because again, computers don't really understand text, but they do a really nice job with these values, right? So you can see the 9906 here corresponds to hello, right? 122332 corresponds with this community, right, component, and so it's basically just a mapping, right, between, hey, let's turn a vocabulary, a set of words that we know about, into numbers that can then be processed by the computer. So I hope that helped answer that question.
All right, thank you. I see a lot of questions are pouring in, but unfortunately we are running out of time. So I will put the last question, and then we will move forward with the raffle winners to keep your valuable time in the time frame. So thank you guys so much. If Luis would like to get back to your questions later, maybe he'll do, or we can, total up your questions, and then we can invite Luis again one more time, maybe, if he is available for it. So
yeah.
All right, awesome. So for the last question, how can we customize AI processes to our application requirements?
That's a really open-ended one. Because your application requirements are going to be different, right? So that's going to be considerations as to, like, am I using B? Am I using GPT? What exactly is it I'm trying to do? I would say like I'll take a step back, and it's just like, really identify the scenario that you're trying to solve, number one, and really make sure to like define what that requirement is for the scenario that you're looking to solve. And number two, ask yourself, do I actually need AI? Because sometimes, yes, AI is exciting. Yes, AI is very cool what it can do. But at the same time, you sometimes don't really need AI for some stuff, right? So like you could basically do like a SQL query and put up a dashboard, and that's going to work really nicely and answer the questions that that you want to know about your business or whatever process, right? So I would say, like, really start with defining what exactly is the problem that you're trying to solve, and see if like AI helps. And if not, that's okay too, right? Like not everything can and not everything should, sort of be solved with AI, right? Like there's much simpler cheaper, like, types of solutions that, again, your application requirements are going to sort of dictate.